Hi everyone. So today I'm going to be walking you through our interactive visual analytics dashboard for CSE 564, and it's built by myself and my partner Naseer Ahmed. So our project is called the U.S. County Health Inequality, and we're working with the County Health Rankings dataset, which covers 3,143 U.S. counties, and it includes 16 health and socioeconomic variables. And these variables include things like life expectancy, income, smoking rates, access to primary care physicians, poverty, and more. So the core question that we're trying to answer is where in America are people the least healthiest and the most healthiest, and why? Is it just geography? Is it income? Is it lifestyle, access to healthcare? So our dashboard is designed so that we could explore all of these questions interactively using the linked brushing across our 5 different charts. Now, let me start by giving a quick tour of our layout. So on the top left, right here, we have the geographic uh, choropleth map. And then on the top right of it, we have the parallel coordinates. And then in the bottom, we have our 3 charts. We have the scatter plot, the state box plot, and the ranked county bar chart. So every chart is fully linked. So selecting one data or highlighting a certain number of counties in one plot will reflect it onto the rest of the plots as well. So starting off, let's start off with the first plot that we have, which is the geographic map. And this is currently showing the life expectancy map variable. So the map variable is what coordinates the variable for each of these plots, except for the scatter plot, which is controlled by the scatter x and the scatter y variables. So on the geographic map, we just see that this is the most immediate way to see health inequality across the country. And each county is shaded by an active variable, which is currently the life expectancy. And we could see that the color goes from yellow all the way down to dark red, which goes from basically the lowest life expectancy to the highest life expectancy. Now, the first thing you'll notice in the pattern that it is quite dark in the Appalachian mountain area, which is near like Kentucky, West Virginia, as well as the deep south in the Mississippi. Um, and that is pretty drastic compared to the region around it. So the region around it, we could see that right above and below the Appalachian Mountain area, the life expectancy is in the low 70s. But then along the Appalachian Mountain, we could see that it goes mostly towards the 80s. Now, I want to show a relationship on the map. So if we go over to the map variable up there and we change it to median household income, let it load, and we could see the same geographic pattern on this as well, where it's darker near the same region, which shows that there's a higher income along that pattern compared to the area right above and under it. So we could see a clear relationship between the life expectancy and the median household income data. So now I want to show one more. If we go back up to the map variable, and this time let's choose percent of adults reporting currently smoking in the area. And again, we see the same pattern, but this time it's an inverse relationship. So the pattern where the region where the life expectancy is the highest, we could see that the smoking rate is the lowest, and that is what we would expect. And once again, right above that area, we could see that cluster of red, which shows the high smoking rates, which correlates with the low life expectancy. And we could see that these variables are actually these variables are geographically related. And we're going to look more into that once we get to the scatter plot. But now, for now, let's move on to the parallel coordinates. So starting from the very starting from the top, the first variable that we have, this chart first shows every single county as a line that threads through all of the 16 variable axes that we have, the 16 variables. And each vertical axis represents one variable, and a county's value on that variable is where the line crosses that axis. the lines are also colored based on the life expectancy. So we're just gonna go on the top variable up there on the map variable, and we'll just change that back to life expectancy. So now we could we could immediately see the green lines that's going across the healthy counties, and that tends to sit high on the income and the PCP rate, while the red lines sit in the bottom, and there's a very clear visual fanning pattern that's going on over here between the green and the red. Now, we could brush through all of these filters, but let me try to select some of the high life expectancy just to grab the top counties. There we go. And we could see that they follow a very clear pattern over here. We could see that they are correlated with low percentage of poor health. We could see that they have very low injuries, and we also see that they have very low smoking percentage all the way to the right and low percentage of rural areas, which is exactly what we saw on the geographical map there on the left. Now, one relationship I want to point out here, though, is the YRLL rate, which is basically the YPLL rate, which is the years of potential life lost. And these first two variables essentially measure the same thing, because if a certain county has high life expectancy, we would expect it to have lower potential um, life potential years of life lost. And that is exactly what we're seeing here. And we could make this more clear by selecting actually the bottom life expectancy counties. So if we select some of these ones in the bottom, we could see that they're going to have very high YPLL rate, meaning that there's a lot of years of potential of life loss there due to some of these other variables that we're going to go through. So we could see that low life expectancy is correlated with poor health. We could do it with it's correlated with poverty. We could see low levels of PCP rates. And one interesting thing, we see very, very high percentage of rural area, which is all the way to the right, as well as smoking. So those two seems to contribute a lot to the life expectancy of a certain county. Now, um, let's clear the selection here again. And now I'm going to hand it off to my partner, Naseer, for the bottom graphs.
Okay. Thank you, Mohtadi, for talking about the top half. I'm now going to be talking about the bottom half of our dashboard. So moving on to the bottom left plot of our dashboard, we have the scatter plot. And right now, by default, it should be showing median household income and life expectancy. And the pattern here is one of the strongest findings in our entire data set. And so we can see that there is a strong positive correlation between median household income and life expectancy. And counties with higher income live longer. And this single relationship explains a large portion of the geographic variation that we saw earlier on in the map. And so we can see a cloud of points starting from the lower left to the upper right, and that counties earning around $25,000 with the median household income have life expectancies as low as 70 to 72 years, whereas counties that earn over $80,000 are almost at or above 78 years. And we can see that distinction right over here. Um, so let me change the x-axis now to smoking rate. And let's see what kind of graph that we'll get. And so kind of intuitively, we see a strong negative correlation with counties that have higher smoking rates. With that, counties that have higher smoking rate will have lower life expectancy. And this relationship is strikingly linear. And we could actually drag a portion of the chart to highlight it. And like we mentioned before, the area right above the upper Appalachian Mountain, we see that they have the highest percentages of adults reportedly currently smoking. And we could also do the same thing with life expectancy, where we highlight the lower part of the graph, which represents less life expectancy or lower life expectancy. And again, we find that within these regions right over here. So now moving on to the state box plot. And so this box plot spans the interquartile range, and the median and the middle 50% of the counties in that state. And the white line inside these boxes indicate the median. And the whiskers show from the 5th to the 95th percentile, and they're sorted from left to right, from lowest to highest medians. And so if we look at the end of the chart, when it comes to life expectancies, we see states such as Mississippi, Tennessee, Alabama, and Louisiana. And these states not only have low medians, but some of them also have wide boxes, which do indicate, for example, South Carolina and West Virginia. And these do indicate a high inequality within the state itself. And so on the right end of the chart that we see over here with Hawaii, Rhode Island, Minnesota, and Massachusetts, we see the healthiest states by median life expectancy. And one of the things to note about this plot is that the width of a box tells us an important story beyond just the median, where some states like Arizona and Colorado, for example, have wide IQRs, the interquartile distance between the bottom and and the top of the box. And this means that some wealthy urban counties in the 80s, this means that they have some wealthy urban counties in the 80s and some rural counties well below 75 in terms of life expectancy. And let me just clear the selection real quick and go back to median household income. And now we're going to talk about the ranked bar chart. And this tells us which specific counties rank at the very top and very bottom for the active variable. And so the green labels at the top are the best performing counties, and the red are the worst performing counties. And so in terms of life expectancy, which we said over here, we see that the top counties are, for example, Summit, Colorado, Oliver, North Dakota, um, as well as Mono, California. And what do these counties have in common? And the answer to that is that they are all either high altitude recreation communities with affluent, outdoor oriented populations, or they are wealthy suburbs of major cities. And so at the bottom over here, we can see counties such as Dewey, South Dakota, Buffalo, South Dakota. A lot of these are South Dakota and North Dakota. And one of the interesting things to note about these bottom ranked counties is that it does include the Oglala Lakota, which is a Native American reservation county that faces some of the most severe health challenges in the country. And it's driven by historical poverty, isolation, and inadequate access. And so that was a pretty interesting find from this graph. Uh, Now I want to demonstrate the full power of the linked brushing. And this has to do with clicking on specific states from our box plot. And so over here, I'm just building our map. And so as I click on these states, every single panel will respond simultaneously. As we can see, the geographic map, the parallel coordinates, and then the scatter plot as well. And On the scatter plot, those selected counties land almost exclusively at the bottom left quadrant, which indicates low income and low life expectancy. And on the parallel coordinates, the highlighted lines all share the same profile with a high YPLL rate, and a high poverty rate, as well as a high smoking rate and a low physician rate. And so the dashboard makes it possible to move from just abstract observation to actual county names. And so McCreary County wouldn't just be like a data point at the end of a chart. It's actually a real community that faces a specific combination of challenges that we can now identify. And so the core finding of this is that the counties at the bottom of the health distribution are not randomly distributed, and that they form a coherent geographic cluster and a coherent socioeconomic profile with low income, high smoking, high poverty, low physician access, and low life expectancies, which are not independent problems, but they're all the same problems. Whereas in contrast, the healthier counties, they scatter across the map in the, let me just click those really quick. They scatter across the map. Uh, as you can see over here. Well, let me get some more. Um, in the New England region. And in the scatter plot, they sit at the upper right, which we can see over here. And on the parallel coordinates, their lines tend to be more green, as we could see from before. There's a stark contrast. And they represent that these counties ride on high income and physician access. And the contrast between these two profiles tells us the whole story of health inequality in America. So finally, just to wrap up our dashboard uses five coordinated views to let users explore health inequality across all 3,143 United States counties. And the geographic map will reveal the spatial distribution, reveals the spatial distribution. The parallel coordinates show the multiple variable profile of any selection. The scatter plot quantifies pairwise relationships, and the box plot compares states by distribution rather than just averages. And so the ranked chart name and the ranked chart name will name the individual best and worst performers. And the key findings that emerge from this dashboard is that health inequality is geographically concentrated within the Appalachian Mountains, the Appalachian regions, the Deep South, and certain Native American communities at the bottom. Second is that the income is the strongest single predictor of health outcomes, and that the correlation between median household incomes and life expectancy is unmistakable. Third, within states, there is an enormous variation that state level statistics hide completely. And fourth is that access to primary care is a critical factor that separates the healthiest and unhealthiest communities. And so, what makes this dashboard powerful is not any single finding, but the ability to move fluidly between levels of analysis, from a national choropleth down to a specific county name, and to see how every variable tells the same underlying story about inequality in American health. Thank you for your time.